Calc AB question 3 from 2007. Alright, let's get busy on this guy. Okay, function f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is described by this thing right here. Alright, so we got f prime, g prime, and these are x values. So if we were looking for f prime of 2, we would get 2. F prime of 3, we would get -4. Alright, let's see what this first question says. Explain why there must be a value r for r greater than 1 and less than 3, so that's between 1 and 3, such that h of r equals -5. Whenever we're trying to prove that a value exists, now whenever calculus uses the word value, it's talking about the result of a function, so we normally call it the y value. So if we're trying to show that a y value exists, what we're going to do, first of all, we can only do that as long as the function that we're looking at is continuous. And since f and g are differentiable, that means that they're also continuous, because you can't be differentiable unless you're continuous. So what we need to see here is we need to see what the value of h is. That's our value at 1 and 3. So what we're trying to do here is we're trying to show that -5 has to exist. So here's a quick drawing for an example. If I were to draw a continuous function like this, and I have a number right here, we'll say at 1, and a number right here at 3, and I find out that this number right here is 8, and this number up here is 10, then I know that a 9 exists between 1 and 3, says IVT, the intermediate value theorem, because this line is continuous, or this curve is continuous. There has to be a point in here that will give me a 9 for my y value. Okay, that's the idea that we're going to use right here. So let's plug in the 1 and the 3 into h to see what we get. So this is A. First I'm going to plug in the 1 to h. So we have h, and we're going to plug in 1. That would mean we have f of g of 1, and we're going to -6 from that. So g of 1 is right here. There's g, there's 1. We plug in 2. See what we get. We have f of 2 now, -6. Now I'm looking for f of 2, so I go over to f, I look at 2, I get 9, so this is going to be a 9. 9 minus 6 is going to be 3. So we get a value of 3. Let's try h of 3. Okay, then we have f, g of 3, -6 equals, okay, g of 3, I'm looking at g, I'm looking down at 3, that's a 4, so I get 4, so I have f of 4, -6, and now we have, what is f of 4? F of 4 is -1, so this is a -1, and we subtract 6 from that, we get -7. Okay, so in this case, we're going from 3 to -7 for our continuous function. At 1, we're at 3. At 3, we're down here at -7. Therefore, by IVT, there exists in R, let's see, R that is greater than 1, less than 3, such that f of R equals -5. I mean, h of R equals -5. Next problem, it says explain why there must be a value c between 1 and 3 such that h prime of c equals -5. Now h prime means that we're going to be seeing the slope of h at some point. So at this point c, we're getting a slope of -5. This requires the use of mean value theorem. Mean value theorem says this: if you got 2 points, any 2 points, and you have known fact that the function that connects those 2 points is continuous. And that means that there exists a C right here somewhere between these 2 points that'll give me the same slope at that one point, the instantaneous slope, as the slope that connects these 2 points. So I just drew a quick line that connects these 2 points, and that would be that has one slope. Okay, that's the slope of a secant line, also known as the average rate of change. All right, now if I connect these 2 points with a curve, whoops, let's do it like this. Okay, there is going to be a C somewhere on this curve that gives us the same slope as that secant line. That's this line right here. That's the secant line. Okay, that means it would be parallel. It looks like right there, if I pick that point and connect it, we have a parallel line. So we have parallel slopes. So we're looking for parallel slopes. So in other words, f of people like to do B first. Doesn't really matter though. F of B minus F of A minus over B minus A equals F prime of C. So the slope at some value C. So that's what we're going to try to show here right now. So what we're doing here is we're trying to go h of 3 minus h of 1, and we're going to subtract 3 and 1. So in the bottom we get 2, and this is magically awesome because now we have h of 3, which is right here. That's negative 7, and then we have h of 1, which is right here. It's 3, and if I subtract those, I get negative 10 right here, and then underneath it, I divide by 2. I get negative 5. Boom. So now, therefore, by the mean value theorem, MVT, there exists a C between, actually I want to write it all, between 1 and 3 such that f prime of C equals negative 5. Alright, cool. So we answered those 2 questions. Let's go on to the next. Alright, for our next one, we're given a new function. W is defined right here as this crazy looking integral function. Find the value of w prime of 3. So that means we got to take this crazy integral function and take the derivative of it. Lucky for you, the intermediate value, no, not that one. The fundamental theorem of calculus part 2 makes this super duper simple. Let's write out what w is. We have 1 g of x f of t dt. Alright, check this dude out. If I want to take the derivative of this doggy, this dude, we don't have to worry about the 1. The 1 is what we call a constant. But we do have to worry about this guy. This is a function inside of the function. So this function inside of the function, because we have a function inside of a function, remember we're doing the chain rule. Whenever we have a function inside of a function, we're doing a chain rule. Now, derivative would cancel out essentially the integral and the dt at the end. And so we would be left with, let's leave that right there, say prime. We'll be left with f of t, or actually f of x, because that's what we would be plugging into it. Actually, my mistake, g of x, because that's what we would be plugging into it. So we have f of g of x, and then we have to then multiply this by the derivative of g. And so since that's the derivative of w prime, and now we're plugging in the 3, so let's plug in the 3 to this. We have f of g of 3 times g prime of 3. So let's do that. Let's see, g of 3 is right here. It's a 4, so this is going to be a 4 inside there. What is f of 4? F of 4 is negative 1, so we have negative 1 times, and we have g prime of 3, which is 2. That gives us negative 2. That's our answer for that one. Letter D says g to the negative 1 is the inverse function of g. Write an equation for the time, or for the line tangent to the graph of y equals g to the negative 1 at x equals 2. Now if we want to write a tangent line, then we're going to write an equation for a tangent line. We're going to need a slope, and we have to also have a point. Okay, we need a slope and a point. First of all, let's get our point down, because points are usually pretty simple to find. Let's find the point when x equals 2 for g prime, or g inverse of g. Now remember, when we do inverse functions, the x is really the y now. So the 2 is right here. Right, where's our y value? Okay, right here. This is the y value of g. So what are you going to get when you plug 2 into g? You're going to get the x value of regular g, or g prime, or g inverse. So we're going to get the x value of regular g. So if I plug a 2 into the inverse of, actually, you know what? I got a better way to explain this. If I had, let's see, we'll call this g, and this is x. Okay, let's plug 2 into g, and we get, no, I'm sorry, we plug 1 into g, then we get 2. If we plug 1 into g, then we get 2. Well, if we look at the inverse function, that means the opposite. The inverse function does the opposite of what the regular function does, and we're plugging in 2, then we're going to get the x value for g. So we get 1. So our point that we're looking at is 2, 1. So there's our point. After we get our point, we need a slope. So to get our slope, we're going to need to take the derivative of this and then plug in 2 to see what we get. Alright, so this might get a little sloppy here. Let's find out. So to find the derivative of an inverse function, you just need this function right here or this formula. We have g prime with g inverse inside of it. Alright, and since we're looking for, this is a formula, just look up derivative of an inverse function, and this is what you'll get. Let's plug in the 2. So if I plug in 2 to this, I already know what I'm going to get. I'm going to get 1. So that means I get 1 right here. Now I just need g prime of 1, and g prime of 1 equals 5, and so this would equal 1 over 5. So there's my slope. My slope is 1 over 5. So now let's write our equation. We have y minus 1 equals 1 over 5 times x minus 2. And there is our tangent line.